Everyone, welcome to Vijay Codes It. Today we are going to deep dive into one of the most fundamental concepts in Apache Spark, transformations and actions. Understanding these concepts is crucial for writing efficient Spark application, and it will also give you edge in the interviews. So the question would be, what exactly is this transformation? To understand transformation and actions more clearly, let's take an example. Imagine you are a chef in a restaurant and you have all the ingredients to prepare a dish. So what you will be doing is you will be chopping all these vegetables, marinating the meat, and keeping it aside and wait for the restaurant to open. As soon as your restaurant opens, you will start getting the orders. And now is the time that you will be combining all your preparations and preparing the dish for the guest. So in the Spark context, you can assume chopping the vegetables as transformations. So transformations are basically preparation of a data. Let's say you are filtering out the data. You are doing join operations. You are doing group by. You are applying map function on the data. This is what transformations are. Actions are basically like doing dot count, dot show, dot save as files. These are what actions are. Hope you were able to understand the difference between preparation and serving. Preparation on data and what actually serving the data is. Now, there are two types of transformations. First one is wide transformations and narrow transformations. So, what exactly wide transformation is? In our previous video, we have seen what a cluster is and how executors are distributed among our cluster nodes. So, let's say we are processing 1 GB of data, and this 1 GB of data is scattered across different worker nodes. So, what will happen is whenever you do a group by operation, it is considered to be a wide transformation because to group a data, we need to shuffle the data across the worker nodes. Let's understand it with the help of an example. Let's assume we have the CSV file for the sales data. For for example, I have taken this table as small, but let's assume that this table is very big and it is scattered across different worker nodes. So what will happen is, let's assume this data, let's assume this data is in executor 1. This row is in executor 1. This row is in executor 2. This one is in executor 2. This one is in executor 2. And this one is in executor 2 as well. So what we are doing is we are grouping the data, and this data is spread across two different executors. So what will happen is in executor 1, we will be having ID 1 and 2. But in executor 2, we will be having ID 1, 3, and 5. And the records for Cynthia, ID 3, would be grouped. But what we have to do is we have to like group by overall. So then this data would be shuffled across, and the ID 1 would be grouped after shuffling. So what we will be having is 1, 2, 3, and 5. So to achieve this, we have to like shuffle the data across the cluster, and this is wide transformation. And we have to avoid wide transformations because it is costly. We have to shuffle the data across the clusters. Now we have understood what wide transformations are. Let's understand what narrow transformations are. Say, for example, in our dataset, a customer can purchase only once in on a given day, and you want to filter out the customer who is spending more than 500 on a single day. So our output would be we will be getting ID2, which is Emily from executor 1, because she is spending equal to 500, and we will be getting ID3, which is Cynthia from executor 2, because she is spending 700, which is greater than 500. And once the executors are done processing the data, they will be sending it back to the driver, and we will be getting it. Here, there is no occurrence of shuffling, hence it is a narrow transformation. So the example of narrow transformations are filter, select, union, map, etc. And the example of wide transformations would be join, group by, and distinct. These are the two transformations, and make sure that you understand it thoroughly because this is 100% an interview question. Now let's understand what exactly are actions. Let's understand what exactly actions are. Actions are basically save as files. Second action can be dot show. Third one can be count. So these are the actions. And whenever we perform an action, the Spark creates a job for us. So action triggers the job. Now let's understand what a DAG is and how Spark does the lazy evaluation. And here we'll be getting a more deeper understanding of what transformations and actions are. So now let's see the theory with the help of an example. What we are doing over here is I'm exporting the COVID dataset from the Databricks, and then we are filtering out on state and the date column. After that, we are grouping the data on the basis of date column, and then we are performing an action. So let's break it down step by step. So when I run the dot read command, we can see that we are getting two Sparks job. Why we are getting two Spark job is because dot read is an action and infer schema is an action as well. Due to that reason, two jobs are getting created. And when we add our next step, that is filtering on state, we can see that there are still only two jobs. Because filter is a narrow transformation and it doesn't create any kind of Spark jobs. Now let's add our third step. Even after adding the third step, we can see that we have only two Spark jobs because third step is consisting of filter as well. Now let's add our fourth step. Even after adding our fourth step, we are getting only two jobs because groupBy is a wide transformation and only an action can trigger a job. Now see closely when we do dot show on this group data, new other jobs will be getting created. See, now we have four jobs. This is because we had two jobs from prior, which is from dot read and infer schema. The other job is created for dot filter and dot show because after dot filter we are grouping the data and it is shuffling the data across. Due to that reason, one job is created over there. We can see the DAG, which is created by Spark. Basically, Spark is skipping the step which is already done, and it is not computing the prior steps, and it is directly taking up the data from the prior step. When we go to visualize the query which is ran by the Spark, we can see that Spark is optimizing our query. We are filtering on multiple steps, but what Spark is doing is it is combining all those steps into one step so that it is saving time and not creating unnecessary data frames. So, here are some practical tips for optimization. First, we need to minimize the white transformations whenever possible. We need to partition our data wisely, and we need to be careful with actions that collect data to the driver. Because what will happen is, say for example, you have requested a driver of 10 GB, and what is happening is when you are doing dot collect and it is bringing the data to the driver, and the size of the data it is bringing to the driver is 15 GB. So what will happen is, in this case we will get an error, driver out of memory. So to avoid this, we need to be careful with the actions. That's it for today. Thank you for watching. Please like and subscribe to the channel.